Morning everyone, my dear children. So today you are seeing so many shapes are here. Is it? Means maybe you are understood what we are going to learn. We are going to learn about geometry and in that also shapes. Again, you know many mathematicians, Aryabhatta, Ramanujan or Pythagoras, Euler. Euler also one of mathematician and he has researched for our geometry. Cosine, sine that you will learn in the 10th standard. But it was a very important and he has researched on it. And that formula of cosine was known as a mathematician beauty in that season. Okay. So today we are going to learn basic of that maths, basic of that geometrical formula. So today our topic is Euler's formula. So today's our topic is Euler's formula. Now see, here you are seeing so many shapes, but all are, now this is a flat surface, is it? And this is a 3D. Why this difference is there? Why we are calling it as a 2D shape and why we are calling it as a 3D shape? Something is there. Can you tell me answer? Yes, this is the rectangle. Okay, and this is also rectangle. But this is called as a 3D shape and this is called as a 2D shape. Why? Because see, this is the flat surface. This is a flat surface. If I keep it on the table, okay, if I keep it on the table, it is occupying only the space of the table. It is occupying only the space of the table. But if I keep this cuboid on the table, it is occupying the length as well as whole the space of the table, and with that it is occupying the space of the air also. It is a hollow shape, and so this is the difference between the 2D shape and 3D shape. 2D is totally flat, but if you combine these rectangles or any shape in the hollow or with the heights, we are getting the 3D shape. See here, this is rectangle, this is rectangle, this is rectangle. We are joining so many rectangles with each other and we are making a box or we are making a shape by using the heights. So this is a flat, so it is a 2D and this is 3D. Understand? We are going to learn about this 3D. Our everything is depend on these 3D shapes. Now I am showing you few shapes. We have already learned from the 5th standard what are the names of the faces or what are the names of these 3D shapes. According to face or according to shapes, we are identifying them. First, see here, we will go for cuboid. Cuboid is having rectangular face. Okay, so see, this is a cuboid. It has a rectangular face. All surfaces of this cuboid are rectangular. Okay, now this is the cube. You know very well this cube. You know very well. Okay, cube means what? This is the cube. This is the cube. Now what is the difference between cube and cuboid? What is the difference between cube and cuboid? See, cuboid is having rectangular surface. Okay, and cube is having square surfaces. If you observe cube, all surfaces are square. And if you observe rectangle, all surfaces are rectangular. This is the difference between cube and cuboid. Next is pyramid. Next is pyramid. If you observe pyramid, now see in cube or cuboid, there are 4 different vertices. That we will go for that. But here if you observe, one face is rectangular and rest all are triangular, and they are meeting in only one point. Is it? Here in cuboid, they are meeting in different 4 points. But in pyramid, they are meeting to each other in the same one point. So this is the difference between the cuboid. Cuboid is also called as a prism. We are going for the prism. Next point. So see, prism. Now this is the hexagonal prism. I have this pentagonal prism. See, this is a pentagon. This side also pentagon, and these points are joined to each other. Okay, these faces are joined to each other. So this is the difference between pyramid and prism. Prism is having different faces, and they are joining to each other with the edges. But here all the edges are having one common point. This is the difference between prism and pyramid. So cube is also cuboid. These are also one of the example of the prism. Rectangular prism is only called as a cuboid. Square prism is only called as a cube. And this is also one pyramid prism. This is triangle. This is triangle. So this base is triangle. So this is called as a triangular prism. Okay. So with the help of these all the shapes, we are going to learn about the Euler formula. Now next, very important, what we require for our Euler formula, that is face, vertex and edge. This is very important for us. What is mean by face, what is mean by vertex, and what is mean by edge. Just see now, I am taking cube or cuboid, I will take, okay. See, I am showing you here also, and I am showing you here also. We will see this figure with comparison of our cuboid, okay. So see, face. Face means what? The side of the shape, means the surface which we can see, that surface, okay. This surface of the any shape is called as a face. Any surface is called as a face. We can say side means side view. We are looking when we are going top. From the top we are seeing our building, that is the top view, top side of that building. So top side, if I keep it down, now top side is coming rectangle. So like this. So that surface, that is called as a face. Okay. Now vertex and edge. First we will go for edge. Now edge means what? Where the faces meet. It is called as edge. Means see here, this is the cuboid. Here this is one face, okay, and this is one face, or this is one face and this is one face. These faces are joining to each other. So this face and this face, they are joining to each other. So here this will be form an edge, where two faces. Let's see this pyramid. In this edge of the triangle and this surface of the triangular pyramid and this surface, they are joining to this edge. Is it? They are meeting to each other here. They are forming a segment. It is called as edge. Okay. So edge means what? Where surface or faces meet to each other. Okay. Now next, vertex. Vertex means what? Where the edges meet to each other. Now for example, see this pyramid only. This edge is coming here and this edge is coming here, and they are meeting to each other in one point. This edge is also meeting them. They are intersecting here and they are making corners. Here is one corner, here is one corner, here is one corner. Same way, here is one corner, here is one corner, here is one corner. So these are the vertex. Plural of the vertex is vertices. So this pyramid is having how many vertices? 1, 2, 3, 4, 5, 6. Okay. So see, vertex means what? Corner or where edges meet to each other. Vertex means corner or where edge or edges meet to each other. It is called as a vertex. So I hope you have understood. Once again we will repeat. See, face means what? Side of the shape. Means this is the side, or this is one side of the shape. This is one side of the shape. So these side or surfaces which we can see, that are called as the face. Edge means what? Here, this face and this face. These two faces are meeting to each other here. So it is called as edge. And these edges, this one edge, this one edge and this one edge, they are meeting to each other in the point. Is it? That corner is called as a vertex, or plural of it, vertices. Okay. So now these all three things we require for our formula. To derive our formula, we require this thing. Okay. So let's come on our derivation of the formula. We will derive our formula now. So what I will do, first we will make columns and we will use all the different shapes. Here we will take object. Okay. Then we will take number of faces. Then we will take number of vertices. Then number of edges. Okay. Then I want, or shall we take it afterwards? So it will be little bit surprise for you for the formula. Okay. First we will count this much only, because I want to make your curiosity as it is. What is the formula and how it is coming, that I want. Okay. So keep your curiosity like that only. Yes. So here we will take object. Then we will take faces, number of faces. Number of vertices. And number of edges. Number of edges. So let's first we will take, I will write with the different colors, so you will get that idea. First we will take cube. Now who will tell me which is the cube? From these all things, which is the cube? Is it cube? No, it is having rectangular surface. Is it cube? No, it is having only one common corner. So it is a pyramid. So is it cube? Yes, it is a cube. Correct. Why it is cube? Because it is having surfaces square. Okay. So let's go for the cube. Count with me. How many faces are there for the cube? 1, 2, 3, 4. Then 5, 6. So how many? 6 faces are there. Now count vertices. Vertices means what? Corners. So this and this. 1, 2, 3, 4, 5, 6, 7, 8. So there are how many vertices? 8. Now count edges with me, everyone. This first we will count for this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So how many edges are there? 12. Okay, this is one. Now let's come on this. This is which shape? Yes, it is a cuboid. Let's count for cuboid. How many faces? 1, 2, 3, 4, 5, 6. How many faces are there for cuboid? I will take different color. 6 faces. Now count vertices. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 vertices. Now count edges. 1, 2, 3, 4, 5, 6, 7, 8. Now height. 9, 10, 11, 12. So there are how many edges again? Oh, cube and cuboid having same, no? Okay. We will go for another. Go for this triangular pyramid. Different color. Triangular pyramid. Now see the faces. These two triangles. So 1, 2, 3, 4 and 5. So how many faces are there? 5. Now take vertices. 1, 2, 3, 4, 5, 6. And now take edges where faces are meeting to each other. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 edges for the pyramid. And now take one prism, and now take for pyramid. This is pyramid, rectangular pyramid. So take for this yellow color. Rectangular, triangular, prism, and here we will be taking pyramid. This is the prism. Oh, sorry. This is triangular prism and this is the rectangular pyramid. Okay. So see, let's count for pyramid. 1, 2, 3, 4, 5. How many faces are there for triangular pyramid? 5. Now how many vertices? 1, 2, 3, 4, 5. How many edges? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 edges. Now what I am going to do, I am adding here one more column. And this is the starting of our formula. This is the starting of our formula. What? I want to add faces and vertices. This is our F faces. These are our vertices. So it will come as a V. And these are the edges. So it will come as a E. Okay. First letter we will take. F faces, V vertices, E edges. Okay. So let's count F plus V for Q. Do the addition. 6 plus 8. It is coming 14. Now do this addition for the cuboid.
6 plus 8 is 14.
Yes, correct. 6 plus 8 again 14. Now take this. 5 plus 6 triangular prism. 5 plus 6 because 5 faces of the triangular prism and 6 vertices. So it will come 11. And now take rectangular pyramid. 5 plus 5, how many? 10. Now tell me what you are observing here. This is and this. If you go for the calculations, every calculation, you will get one pattern. You will get one relation. You will get one pattern or you will get one relation in the operations. So think about it for 1 second. What is the relation or what is the pattern you are getting? You are getting something answer. How we are doing for 1 plus 1, it is 2. 2 plus 1, it is 3. Like that, something is there. If you go for edges and the sum, there is some relation. There is some relation. So now I will add till the time you think about it. I am definitely going to tell, but first you will observe, you will take out the answer, you will see what is the relation, and then I will also tell, because that is the important and that is only our formula, that is the relation. So shall we forward? I hope everyone has done. See, if you see this addition, it is coming 14. And if you observe this number of edges, it is 12. So, if you add 2 in the edges, you are getting 14. If you add here 2 in this 12, you are getting 14. Next, for cuboid, same thing is happening. If you add 2, 12 plus 2, you are getting 14. Same thing will go for prism. 9 plus 2, it is coming 11. Same way, if you add 2 in 8 for the rectangular pyramid, it is also coming 10. Means what pattern we are getting? If we add 2, in the number of edges, we are getting it equal to face plus vertices. Sum of face and vertices, we are getting that. So let's see, E plus 2, I will write here. So 12 plus 2, 14. Again 12 plus 2, 14. 9 plus 2, 11. And 8 plus 2, 10. So, I hope that you have got the formula. What relation we got here? Sum of faces and vertices is always equal to E plus 2. Means if we add 2 in the number of edges, we are always getting sum of face of vertices and faces. So what's formula we have derived here? So our formula is telling that this is our very important formula. F plus V is always is equal to E plus 2. This is the Euler's formula. This is Euler's formula. What he has researched, sum of faces and vertices is always equal to sum of edges plus 2. It is always equal to sum of number of edges plus 2. So this is our topic, and which is very important research by Euler in the geometry, because with this formula everything sine, cosine, and with the help of that everything is derived. Everything, this is the base. This is the base for the 3D shapes, and this happening for the 3D shapes. But after that we are going to see, is it possible for curved lines, because till the time whatever we have seen, everything is in the straight. Is it? This is the straight edge. This is the straight edge. This is the straight edge. Everywhere, whatever examples we have seen, everyone was having straight edge. Is it? So I hope you have understood what in Euler formula, number of faces if we add with the number of vertices, we are getting it is equal to number of edges plus 2. Okay. So now I will draft this and you will tell me for few examples. What is our formula? I will write it up and we will go for the different examples. F plus V is equal to E plus 2. I will write this E so you will understand it properly. Instead of running cursive, I will write here E, and this F also I will write in normal form so you will understand it. Faces, vertices, edges and plus 2. So now you will tell me, if it is a pentagonal prism, what will happen with this prism? How many faces, how many edges, you will count and you will tell with this formula. For pentagonal prism. Pentagonal prism is also called as pentagoid. Hexagonal prism we can call as a hexagoid, because cuboid, this you already know, rectangular prism, that is the cuboid. Pentagonal prism, pentagoid. Hexagonal prism, hexagoid. Okay. So pentagonal, in this name only you can understand. Pentagon means how many edges? 5 sides. So this face is having 5 sides, this face is having 5 sides. So one we will take on this, and one example I will just give you to solve. You will think in your mind how many faces, how many vertices, how many edges will come to that. Because now only we are seeing so many examples and we can understand, because every vertex is joining. Is it? So you will tell me, this is the pentagonal prism. Count it. First we will count faces. 1, 2, 3, 4, 5, 6, 7. So how many? 7 faces are there. How many vertices? 1, 2, 3, 4, 5. This side also. 1, 2, 3, 4, 5. So 5 plus 5?
10.
10. So there are how many vertices? 10. Now count number of edges. Already this side is having 5. This side is having 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 5 plus 5, 10. Now start from downside. 11, 12, 13, 14, 15. So how many edges are there? 15. Now check out for formula. Is it true or false? How many faces? 7. What is formula? F plus V is equal to E plus 2. Put the values. Faces 7. Vertices 10. Now check for edges. 15. I am not putting here any sign because we have to check out. Is it? So 15 plus 2. Now check this sum. It is coming 17. This sum is also coming 17. 17 is equal to 17. So this formula is useful for the pentagonal prism. Then let's come for this curve. This is the cylinder. It is the curved surface. So can you tell me edges? It has no edge. Is it? Same thing will happen with sphere. It has no edge. And cone, it is not having edge. So this formula is not useful for curved edges. This formula is not useful for curved edges. So today what we have learned? We have learned Euler's formula, and today's homework for you, you will count and you will try is this formula is true for hexagoid or nanogoid. Okay. So tomorrow we will meet again with the new ideas. Have a good day.